Gotta get my fingers ready for this. I don't know why. Well, this is the first one for me, checking out the graphics card from ASRock. Yeah, that's right, a graphics card from ASRock, another motherboard. Hi guys, Matthew here and welcome back again to my channel. Although I did encounter their RX 590 Phantom Gaming graphics card model in one of their themed builds, I didn't have a chance to check it out in detail, and this one is of course the new Navi-based RX 5700 XT model. Plus, this one is coming as a part of their Taichi series, so that's the RX 5700 XT Taichi OC Plus model, another Phantom Gaming one, which also has its own lineup for current gen Navi models. Hopefully I will get a chance to check them out soon too. This card right away demands to be looked at. It's definitely not your ordinary model. This is even more pronounced once you actually plug the card into the system, as this middle fan has its own little RGB light party going on. Yeah, kinda looks weird with only it and this LED strip around it glowing, like the rest of the two fans didn't deserve that too, which makes it appear like something is wrong at first, not working, as it doesn't look uniform, and to me like this it looks quite tacky. Other than that, I do like this more open style shroud design, it looks pretty unique. They went for that industrial angled shapes with clean cut look. This part reminds me of Cooler Master's Cosmos chassis and its top handles. I feel like taking this graphics card to a LAN party. Come on, let's go, I have enemies to conquer. What's also unique is its metal backplate, which I really like. It's simple yet still has a lot of going on, like this gear which has a 3D texture to it. I also like that they've put marking for their switches on the back. For example, you have a dedicated switch for turning on and off RGB lighting, while this is a dual BIOS card, so it also has a switch for that. One position is for the normal OC BIOS profile and the other one for the silent BIOS profile, so you know which one is which, unlike with Sapphire's cards for example. Speaking of that, be sure to subscribe if you haven't already, because I also have Sapphire's RX 5700 XT Pulse model in line. That's the final piece of the puzzle, since that's the only model I haven't tried from their Pulse series. As you've probably noticed, the card itself is really big, measures 324mm of length, although the PCB is actually a bit shorter than that. It's 2.5 slots tall, while it's also a bit wider and weighs in at just a tad above 1.2 kilograms. This is before all due to its big cooling solution. We have a two-part aluminum heatsink configuration connected with 5 nickel-plated copper heat pipes. Since this is a custom PCB design with an upgraded 10+1 phase power design, ASRock decided to pull the GPU more to the front of the board, which looks a bit unusual at first, and above it we have that smaller portion of the two-part aluminum heatsink array, which is making contact with it over the copper base plate together with the heat pipes just behind it. You can also notice a big cold plate going around the GPU and power delivery system, covering a large surface area, pulling the heat of the video memory, while the VRM and power design itself have direct contact with that bigger part of the aluminum heatsink on the back. All of this is topped off with two 85mm fans and one middle 75mm, which turns in the opposite direction of them for better cooling efficiency, while they have 0 RPM 0 dB fan mode, in which case the GPU temperature during idle didn't went over 50 degrees Celsius. As for keeping the temperatures down under load, it did that to a decent degree, no pun intended, better than the reference model for sure. During gaming that was mostly between low to mid 70 degrees Celsius for the GPU, a bit higher junction temperature, above 90 degrees Celsius, while the memory and VRM temperatures were okay. With this level of cooling performance, overall it put itself somewhere in the middle of the offering when it comes to aftermarket RX 5700 XT models, at least from what I've tried so far, but I was honestly expecting a bit lower GPU temperatures, having in mind the size of its cooling solution, especially considering that the fans were spinning pretty fast, around 20 to 2100 RPM. With that in mind, I started looking at other reviews of this card, and what I saw is that some reviewers had better temperature results with their sample, while some did have similar or even worse experience than what I had, which got me thinking that it could be due to thermal paste or its application. It was possible that this card has been reassembled multiple times as it passed through hands of different reviewers, and actually this torn up seal on the screw indirectly backed my theory. Lo and behold, after reassembling the card and putting a fresh layer of thermal paste, I took it for a spin again, and would you know, both GPU temperatures were much better. Now the GPU temperature was roaming around 70 degrees Celsius, while the GPU hotspot temperature was mostly below 90 degrees Celsius. All in all, a major improvement which basically required no effort, just 10 minutes of your time, and that seems to be a pretty common go-to solution for this series of Navi cards nowadays, as I see a lot of users doing the same. I also noticed one thing, and that is that this card's GPU runs at 1.2 volts, which is really high compared to others, and the situation is fairly similar to one that I had with XFX RX 5700 XT Raw 2. Feel free to check out my review of it, I will put the link in the right top corner, which was running hot out of the box and which buyers also tend to repaste. I actually got a few of your comments on that video in regards to some of you doing that. With that said, I've managed to pull down the GPU voltage to below 1.1 volts, which obviously resulted in lower temperatures, way below even compared to the improved results as you can see it here, while maintaining the same GPU clock speed. This will also enable you to make a custom fan curve since you have more headroom in terms of the GPU temperature, so you can make the fans run below 2000 RPM, while in this case it did that inherently as the temperatures went down, so they were anywhere from 1500 to 1700 RPM. Here's a short sound clip of the fans with the card being under full load in those two scenarios, while also showing you the sound meter for a measurement comparison. Before I go to my benchmarking results, let's first take a look at some of my gameplay footage with this card. You can see the live performance figures of it in the left top corner of the screen. And if you have any questions about this particular model, feel free to leave them in the comment section down below and I will try to help you out.
Did someone call a doctor?
Looking at the benchmarking results, generally speaking, there's no surprises here for me, and I'm guessing for you too, as you're also probably pretty familiar with the overall performance of this series. Bottom line, it's ideal for 1440p or 1080p high frame rate, high refresh rate monitor gaming, while 4K is also doable if you go easy on the graphics settings. The results are more or less the same compared to other aftermarket RX 5700 XTs out there, as the difference in GPU clocks between them end up delivering results which fall under a margin of error. What's interesting about this model is that its claimed factory overclock and boost clock is one of the highest I've seen, just a bit above 2 GHz mark, although in reality the working frequency was mostly below that, anywhere from 1970 to just below 2000 MHz for the most part, but rarely above that. But what I've also noticed is that its frequency overall didn't fluctuate that much compared to others, it was mostly in that upper region, hanging on to it. Stretching its potential with my usual overclocking procedure, it managed to stay above 2050 MHz under load, while the video memory clocked to a tad below 1900 MHz, and all of those clock improvements in the end resulted in about 3 to 5% of additional performance gain. The card pulled anywhere from 200 to 230 watts according to the GPU-Z readout, with everything being as it is out of the box, while the power meter indicated that's more around 270 to 290 watts from the wall when you subtract system idle power consumption from the total system power consumption under GPU only load, that being Firmark's GPU stress test. Lowering down the GPU voltage to levels I mentioned earlier, the power consumption goes down by about 30 to 60 watts across the range, which is a significant difference in terms of card's power demand. Speaking of it, for that we have not one but two 8-pin PCI Express power connectors, so that's a non-standard power connector configuration, which is not a surprise considering the upgraded power delivery system. What's also by a mile non-standard is the fact that we have a total of 6 video outputs, 2 HDMI and 4 display ports, which yeah, rarely anyone will actually use, but it's still nice to have them, why not, it doesn't hurt, especially for VR users. Although it's in a way weird to put ASRock and a graphics card in the same sentence, I'm really glad that they decided to enter this market with their own custom solutions of GPUs. The only thing that's a bit questionable for this particular model is its pretty steep price tag. It's definitely one of the priciest RX 5700 XTs available, and even with its decent performance, overclocking potential and cooling capabilities, once you tweak it that is, I feel like everything should be basically next to perfect for this price point, even more so since it's so close to Nvidia's RTX 2070 Super Series. That's it for this time for me. Thank you once again for watching. Please take a second to toss me a thumbs up if you enjoyed my content, that really helps a lot. And if you like what you saw, feel free to subscribe, and if you already are, be sure to press that notification bell down below so you don't miss out on a new video. And until then, catch you later guys.